particle travels with uniform acceleration between three posts, equally spaced 38 meters apart. It passes the second post 4 seconds after passing the first post and passes the third post 2.5 seconds later. Find the particle's acceleration and B, the particle's velocity when it passes the first post. Now, there are two ways of doing this, so I'm going to show you both ways. Method 1 involves a little bit more working, but it does lead to easier simultaneous equations to solve. Okay, what you should do in this situation for both methods is draw a velocity time graph. Okay, so we have time here and velocity here. We have u, which will be the starting velocity, which we'll have to calculate. And we know that this is a straight line because we have uniform acceleration, so this has to be a straight line. And what we do, we remember that the distance or displacement is represented by the area underneath the graph. So we've got what first post here, second post here, third post here, and we know that this must be 38 in this case, and this will be 38 in this case. And then we just use, in fact, we need to find V1 and V2, but we won't actually find those values, we'll just set up equations with them. So we're going to consider this one here. So between the first post and the second post, we'll find that the velocity is equal to u plus at using that Suvat equation. And then that's going to be u plus 4a, because the time here is 4 seconds for V1. And then for displacement, we're going to use s plus v times t over 2. It's basically the area of that trapezium. So that's going to be 38 is equal to u plus v1, so that's u plus v1 times by the time, which is 4, and divided by 2, so the area of a trapezium. Okay, if we rearrange this one, we're going to get u plus v1 is going to be equal to 19. That's 19 comes from doing 2 times 38 divided by 4, and therefore v1 is equal to 19 minus u. Now, because we've got v1 here and v1 here, we can equate those two. So equating them for v1. Okay, we're going to have 19 minus u is equal to u plus 4a, and then we're going to have 2u plus 4a is equal to 19. We're going to call that equation 1. And then what we're going to do, we're going to do the same, but we have to consider this because we want u in it. This trapezium here. So between first and third post, don't try to do the second and the third post because it won't work. Be V2, which is that one there. V2 will be equal to u plus 6.5a. And then the area will be 76, 38 plus 38 is equal to u plus v2. So it's the area of this big trapezium here, divided by 2 times the time between them, which is 6.5. So rearranging this, 2 times 76 divided by 6.5 actually doesn't give a very nice number. So it's 304 over 13. So use the fraction button on your calculator. It might help you much easier to avoid decimals. So u plus a v2. And therefore v2 will be 313 minus u. So we're going to equate these two now. So equating them for v2, we're going to have 304 over 13 minus u is equal to u plus 6.5a. So moving that along and writing down the same thing again. And then simplifying that, it's going to give you 313 is equal to 2u plus 6.5a. Call that equation 2. We're now going to solve equations 1 and 2 simultaneously because we've got 2 unknowns, so we need simultaneous equations. So there is equation 1 and this is equation 2. Okay, the advantage of this method is that if you subtract, the u's will disappear every time. So you've got 57 over 13 is equal to 2.5a, and the a will be 1.753, which will give me 1.75 meters per second squared. If we now substitute that into equation 1, we're going to get 19 is equal to 2u plus 4 times this number here as a fraction. So you can use that S to D button on your calculator. And so that gives 19 is equal to 2u plus 456 over 65. And then 779 over 65 is 2u, and that will give that u is 5.992, which we'll call 6 meters per second. That's method 1. Now method 2 is made the workings a little bit easier, okay, because it just involves one Suvat equation. So what we're going to use, so between 1 and 2, we're going to use the Suvat equation. S is equal to ut plus a half at squared. We can use Suvat equation because we've got constant velocity. So in the first case, between the first and the second post, it's going to have 38 is equal to 4u plus a half a times 4 squared. The 38 will be equal to 4u plus 8a. We'll call that equation 1. We'll do the same between posts 1 and 3. Don't try to do 2 and 3 because it won't work. So we've got 76 is equal to 6.5u plus a half times 6.5 squared. That gives 76 is equal to 6.5u plus 21.125a, equation 2. If we solve those simultaneously, and I just use the calculator solver here for simultaneous equations, you're going to get the same answers as before. A is 1.5 meters per second squared, and u is 6 meters per second squared. Okay, so this has been a video to show you how to set up simultaneous equations using Suvat equations and then being able to solve them. Now, for both of these questions, there is a GeoGebra app, and the links to these I will put in the notes of the video. I thank you very much for watching, and I hope you've understood.